Hello everyone. In this video, I would like to show the modeling manipulation after the sketch and continue until the mesh generation of the FEA model. And in this video, we are able to define material property and assign section property to the parts and assemble the wheel and the pinion parts and define and manage steps, contact and its property, and define tight constraints of the property of the part, and impose the boundary conditions to the assembly, and finally apply the loads. Now, okay, let's open the files. Okay, the CAE files is here. So now we should be able to see there are totally 6 parts of the wheels and pinions respectively. And now we can define the material property by clicking that. So right click, we can name it as steel. And there are several properties we need to modify, but the most important one is the elasticity of the material. So keep the default value of the options, but input the Young's modulus and the Poisson's ratio. And click OK. There we go. And we can define the sections. So basically there are 2 sections. The first one is the section of the rim. Let's select solid and homogeneous, and let's assign the thickness. Okay, a similar operation for the pinion, section pinion. Same as solid and homogeneous, but the thickness should be different. Say it's 30. Okay, so now let's assign the define section property to the parts. So please note there are totally 6 parts, but there are only 4 parts to be assigned with the property because the rigid part doesn't need a section property. So let's move on to the wheel. Let's assign it and make it current. So we can assign the pinion as well. Select the corresponding one. Yep. Finally, let's move on to the wheel. Okay, assign the section. Okay, I select the pinion. Okay, that's it. Okay, now we have finished the section property. So let's see. Okay, this is properly defined here. And now let's move on to the steps. So no, sorry, let's move on to the assembly. We need to make all of the parts as instance now. So let's create part as dependent, which means we mesh it on the part. So let's select them all and click OK. So we can see, okay, there are instances in our modules now. We can see they are here. Now let's address the central distance. So you can select all of them by dragging or select one by one. So let's translate it. Okay. Use the value you would like to apply, but currently for me is 293.4 millimeter. So let's see, this assembly is now with that position. You can also rotate the wheel or the pinion by a certain angle. You can select that one by dragging, or just one by one clicking about that reference point. by a certain angle in degree. But yeah, I would like to keep as the original one. Now the instances are there. Okay, let's move on to the steps. We need to define 2 steps, basically. And the first one, we can call it apply torque on the pinion. So the time period we set about a very small duration is 0.1 seconds. And let's turn the nonlinear effects on, and we can set the maximum number of increments in this step and the initial, minimum, and maximum increment size of the step. Okay. For example, we can choose that combination of parameters. Let's click OK. Okay, next step, similarly, we can define apply rotation after the apply torque. Okay, let's modify the time period about 35 seconds. It's a long step. Now we can add some description. For the incrementation, we can modify the values there as well. That's 200 for the maximum number. Choose a combination of initial, minimum, and maximum increment size for this step. Okay, let's move on to the field output request. So for both steps, we need the stress, we need the displacement and the contact as well, but we don't need the force and the reactions. Also, to save time and the space, we just need the very last increment. For the history output, we don't need in this project, but we could ask them in the future projects. Now let's move on to the interactions, actually the contacts between the gears. So let's define the contact property first. Okay, we apply a frictionless contact between the gears. So basically we define the tangential behavior and the normal behavior as well. There we go. Okay, let's define the where is the contact. So basically we can name it gear contact and the step from the applied rotation. Okay, select that one. And let's select all of the surface of the pinion, but deselect the arc. Okay, that's the surface we want. And let's move on. Let's show all of the, let's show the wheel. Similarly, select all and deselect the web. Same idea, but we select the contact interaction property as the frictionless. Keep everything as default. And we can show back. Show all. So we can double check, okay, the contact is defined between the gear surface. Now let's define the tie contacts between the rigid surface and the web, and as well the web to the gear teeth part. So totally there are four constraints. Let's define the first one. Okay, select the rigid one. Select direction. Yeah, because they are coincide together, so like 0. Yeah. Let's select second one. Yeah, but they are not necessarily together, so let's set a tolerance as 0.5. Select OK. Similarly to the view part. Create high. You similarly select rigid. Okay, select the surface. Zero. Okay. Select that one. Select the two surface actually, and specify that's a torus at 0.5. Okay, that's that. Now, so there are 4 constraints. You can see. Okay, 1, 2, 3, 4. Okay, let's move on to the boundary conditions part. We need to prescribe the boundary conditions. First, let's define the pin axis. So we need to pin both of the axes. Select that one. Select pin, so they cannot move. And second one. Oh, let's redefine it. Okay, that's correct now. 0 there, yeah. So you cannot rotate. And define the rotation angle of the wheel at the apply rotation step. Select the reference point of the wheel as minus 0.61, which is equivalent to 35 degrees roughly. Okay, let's define the load of the torque. Okay, let's name it torque. It starts from the second step, the apply torque step, and let's select the type of the load as moment. Yeah, and continue. I select the reference point there, and select the value of the torque. Okay. Okay. Okay, let's open the manager of the boundary conditions. So because in the third step, we need to free the wheel. Then so we deactivate the boundary condition of that at that step. So that's it. Dismiss. Okay. So let's double check everything is okay. So now we have the assembly. We assembled the parts together. We apply the interactions. We apply the boundary conditions and the loads. So everything is ready. So next video I will show how to discretize the mesh. Thanks for watching. See you in the next video.